Hi, welcome back to this video. Remember, in this video, we are studying organic chemistry. So now the first homologous series that I said I will be discussing with you, it is an alkene. We have already covered some of alkanes, and I said, remember, we're going to ask ourselves only 3 questions. For the alkanes, I didn't do that. Okay, I just did a recap on the slides for the alkanes. So here under the alkenes, what I will be doing is I will be talking about the synthesis, the reactions again of the alkenes. Remember, I'm not gonna yet discuss the IUPAC naming because really we do not have time. So I'm just going to focus only on the parts that has a lot of marks that most definitely we are going to be assessed onto. So now, yes, let us start with alkene. We know that the alkene is a double bonded, it's a molecule that has double bond between the 2 consecutive carbon atoms. If you have a carbon atom just like this, bonded to this carbon atom just like this, and then you put your second bond, we know here we are talking about the homologous series, the alkenes. And again, you have to know that the alkenes are unsaturated hydrocarbons. So now, continuing with the lesson, these are the 3 questions that I was actually talking about. Remember, 3 questions: the IUPAC naming of the alkenes, the synthesis of alkenes, and the reactions of the alkenes. So I'm only going to focus on part number 2 as well as part number 3. So when you talk about the synthesis, we are talking about the formation of alkenes. And then these syntheses, they are also called the reactions. So that means you're going to take a certain species, maybe you'll react with another species, or you will just use what you call the catalyst, the reagent, or whatever the case may be, to form an alkene. Okay, so formation of an alkene, it is what we call a synthesis. And you have to be able to understand that how can we form a certain organic compound, and that certain organic compound will react again to form another certain organic compound, and that certain organic compound will react to give the final product, which is an alkene. For an example, we can have product A, we can have reactant A reacting whatever to form reactant B. Product B. Product B, it is a certain organic compound. Product B will have to undergo a certain reaction once more again to form product C. Product C, meaning it is not an alkene. These are not alkenes. Maybe it's whatever, alcohols, whatever. And therefore, this product will undergo another certain reaction now to form an alkene. This is the reason why we need to learn the synthesis. We need to learn the synthesis to see whether which reactants forms which kind of products. So you will see there is a mini synthesis that we're going to discuss under this synthesis of alkene. So remember, these are 3 questions that we need to answer by the end of this chapter. Synthesis: what are the reactants that interact to form the products which are alkenes? So now let us go through these 2 parts, part number 2 and part number 3. But firstly, today on this video, I'll be discussing synthesis. Now, part number 2, which is the synthesis of the alkenes. From this slide that our lecture is going to assess us onto, we're only going to talk about these 2 types of reactions under the alkenes. These reactions, they form the alkenes. So that means the first reaction, it is called elimination of alkyl halide. The second reaction is called dehydration of alcohols. So obvious, we're going to start with the first reaction, which is called the elimination of alkyl halides. So that means we have organic compounds that we call the alkyl halides. Alkyl halides will undergo certain reaction to form an alkene. We have another type of reaction which we call the dehydration of alcohols. So that means if we take an alcohol which is a homologous series or an organic compound, this alcohol will undergo this type of reaction which is called dehydration to form an alkene. So that means alkyl halide and alcohols, these two organic compounds, they can form an alkene. What did we say? Alkyl halides, I'll just say AH, alkyl halides will form an alkene. Through which type of reaction? Elimination reaction. Elimination reaction. Another type of reaction that can form an alkene, it is called the water dehydration. So that means an alcohol will undergo what type of reaction? Dehydration. To form what? To form an alkene. So this type of reaction is called what? It is called dehydration. So when you talk about elimination, we are removing. When you're talking about dehydration, we are also removing. So that means dehydration, it is also regarded to be an elimination reaction, okay, which is dehydrating alcohol. Right. So let us go through elimination of alkyl halides. Now we are starting with the elimination of alkyl halides. It's very important to be able to see the reaction. So we have reaction number A and reaction number B. Reaction number A, it is called substitution. Reaction number B, it is called elimination. Remember, we are only going to talk about the elimination under the elimination of alkyl halides. How many reactions are found under elimination of alkyl halides? This is one. So this one reaction, this is an alkyl halide. How do we see it's an alkyl halide? It is the organic compound that has an alkyl, a halogen group in it. So we're gonna take this as an alkyl substituent, and then this BRS a halogen, hence why alkyl halide. So this alkyl halide will react with a nucleophile or will react with a base. When it reacts with a base, a nucleophile will be formed. This type of reaction, it is called SN reaction. It could be SN1 reaction or it could be SN2 reaction. But what is important here, based on what we have assessed, we have to understand that we have this type of reaction which is called elimination. And this elimination, it forms a double bonded molecule. This double bonded molecule, it is called an alkene. So that means alkyl halide supposed to react with what? That's the very important question. Alkyl halide supposed to react with any organic with any compound. It could be base, any nucleophile that will be able to eliminate Br and this hydrogen atom, and therefore these free radicals, they will fall to form what you call a double bond. Remember, I'm not going to discuss the mechanism on how this reaction actually takes place. What's important is know the reaction that forms an alkene, and therefore this reaction we are eliminating. What is the name of this reaction? It's elimination reaction of an alkyl halide. So we can see that the interest, it is our double bond. Now, you are wondering what's happening with reaction number B. Reaction number B, it is called substitution. Now we are also talking about the alkyl halide. We can see that we have Br over here, and then we have the hydrogen over here. Still, our alkyl halide will interact with our nucleophile, in this case, which is OH minus ion. We really do not care what are these nucleophiles. It only depends. But be careful on how you treat your nucleophiles. So here, this nucleophile interacts with this, but rather instead of elimination, it happens that here substitution takes place. So that means where Br is and then OH is, there will be a substitution. So that means this OH will get into this space, and this Br will most definitely leave as a living group. And therefore, we have this organic compound over here as our product. But this organic compound, this organic compound, it is not an alkene. But you have to understand that we're under the dehydration of alcohols. Let me accelerate you a little bit. Under the dehydration of alcohols, when we have alcohol like this alcohol can undergo a dehydration reaction now to form an alkene. So you can understand that this is a mini synthesis that we can talk about. That means from alkyl halide, we can form an alcohol. An alcohol now can form an alkene, which is what I have just discussed over this slide over here, that you have to understand that A, B to C, finally you will end up with an interest molecule, which is an alkene. So this is what is basically taking place, okay? We needed this reaction to see that or for me to explain to you that this alcohol, after the formation of this alcohol, it can undergo dehydration to form an alkene. Okay, so that's what they have learned. What have we learned? We have learned elimination of alkyl halide. It can form an alkene using what? Remember, using a nucleophile or a base. Okay, we use a base or a nucleophile. So this base will dissociate into ions, and therefore the nucleophile will attack with SN1 mechanism or SN2 mechanism to form this product over here. So now let us repeat the very same elimination of alkyl halide. So the repetition of the very same, but now I want you to pay attention. Here, it was just a presentation. How does the reaction take place? Now here we are dealing with organic compound. This is an organic compound. You see here there are no hydrogen atoms. So this is the repetition of B. Repeat B. So now let us see how does the reaction actually takes place. Sometimes you will be given this, and then they're gonna eliminate the products, or they eliminate the products. They give you products and they eliminate the reagents, and they ask you to write the reagents over there. So elimination of this, it's an alkyl halide. How would you see it's an alkyl halide? Because we formed the double bond using these nucleophiles over here. So now, what is a nucleophile? A nucleophile, it is a species that loves nucleus. Nucleus, it is positively charged. So that means nucleophile, it is negatively charged. Can you see over here? So that means our nucleophile in this case will be this organic compound, or this molecule over here. I don't know if you remember this from the some slides there. I think under carboxylic acid or somewhere there, formation of this salt. Blah, blah, blah. Okay, this nucleophile, what we'll do is will be able to eliminate, like I said, we're not going to discuss the mechanisms. This nucleophile will be able to eliminate what? Br from this molecule will also be with interaction of this alcohol. So that means we can see that we're going to use our nucleophile in this alcohol to eliminate Br and H. Br and H, they're going to leave, and therefore you're going to form a double bond between the two consecutive carbon atoms. And then here, two products can be formed. We can see that here we have 89% formation of this, and then here we have 19%. So it is likely that this reaction, it forms two products. I understand we have the minor product, we have the major product, but that will be under the regioselectivity. Here, we are actually forming two products which follow Saytzeff's rule. So that means when this reaction takes place, wherever where Br was attached, it's either this double bond will be formed this side, or double bond will be formed this side, because we can see that this molecule, it is not a symmetrical molecule, it is asymmetrical molecule. So it's either double bond comes here or double bond comes there, and then we manage to form these products. And you can see that we have high percentages of forming but 2 in rather than but 1 in, based on the Saytzeff's rule. So that's it about the elimination of alkyl halides. Now let us talk about the dehydration of alcohols. Apparently, an alcohol can be converted into alkene once more again. We saw alkyl halide to alkene, now alcohol to alkene. Now let's have a look at this. So we have two reactions again under the alcohols that I'm going to talk about, so that you can see that. Remember, we know that alcohols has classifications. We have primary alcohols, secondary, and tertiary alcohols. And it's very important to take note of those classifications, more especially when you are moving on with the alcohols. So here we have a ring structure of an alcohol, whereby this alcohol, it is a tertiary alcohol. How do we see? This hydroxyl group, it is attached to this carbon atom. This carbon atom, it is attached to 1, 2, 3 carbon atoms. So that means this organic compound over here, which is an alcohol, it is a tertiary alcohol. So what's the name of this? 1-methyl cyclohexanol. We're still doing the naming at least. So this is what is happening. This alcohol, now, it is not the same as alkyl halide, whereby we need a nucleophile. Here, we need a strong base. We need a strong acid. So now this strong acid will help us to eliminate this. Remember, we said we're talking about the dehydration. Dehydration is the same as elimination, okay? We are dehydrating. We are not hydrating. Remember, when you dehydrate, it's when you remove water, right? So that means here on the alcohol, we want to remove water. How are we going to remove water? We're supposed to move OH and hydrogen. So you see, here's the thing. We need a very strong acid and a very high temperature compared to here, which is 25, because you can even see that here we don't even have an hydrogen that we can remove that is bonded to this carbon atom. So based on the mechanisms, that means you're going to have to remove carbon atom over here. So irrespective whether a double bond comes this side or that side, it's going to be the same molecule. So when we remove hydrogen atom over this side, and then we remove this OH, remember here we have an hydrogen. So these two together, they will combine to form water. So that means you're going to have water there. And therefore this radical will fall to form a double bond. Now the double bond is an alkene, alcohol to alkene. What did we use? Strong acid H2SO4. Okay, that's what we used to form 1-methyl cyclohexene. So NB that here we have a, like I said, you can use primary or secondary alcohols treated with a strong acid to afford the best results. These are the best results ever because we use secondary and primary. If you use secondary or tertiary alcohol. Now for the chain, remember this is cyclo and then this is just the chain. So here we are using primary alcohol. Sorry. Here it is a mistake, okay? So here we are still using the tertiary alcohol. I wanted to say tertiary actually. Now we're still using the tertiary alcohol. So this hydroxyl group is attached to this carbon atom, which is attached to 1, 2, 3. Again, this is a tertiary alcohol. So this tertiary alcohol, so that means we're going to have to remove OH and hydrogen. It's either we remove this hydrogen over here or we remove this hydrogen over here. Basically, this reaction and this reaction are the same. The problem here is here we're going to form one product, which is the same because it's either double bond comes here or there, the molecule will be the same. But here we're going to have constitutional isomers, whereby it's either we remove this hydrogen from this carbon or we remove this hydrogen from this carbon. The reason why we use tertiary or primary, it's because in fact the tertiary is the best way to extract the water to dehydrate it. We don't want that hydrogen that is bonded to this carbon. So because we might remove that and then it won't form double bond. So this H2SO4, H2, and then here we have a strong acid. We got temperature compared to that one because the single bond there, it's a chain, it's a ring. So that means we're going to form two products. We're going to form major product and minor product. Again, here we are also talking about the Zaitsev's rule, whereby more highly substituted alkene forms as a major. The more substituted, we need the major. So this is the more substituted alkene. This alkene, it has substituted this side, substituted this side. But this one, it is only substituted only this side and that side. So we need more substituted alkene as a major product. So this will be a major product, okay? Normally in these reactions, we form the major product over the minor products, okay? So yeah, that's what we have learned. And then the recap, what did we learn? Elimination using base or nucleophile. And then we saw that we can use an alkyl halide to form an alkene. We can also use an alcohol to form an alkene. Those are the synthesis. But remember, alkyl halide, we spoke about substitution and we spoke about elimination. The elimination was the one of the interest because elimination managed to form an alkene. What did we eliminate from an alkyl halide? We eliminated halogen and hydrogen. This is what we eliminated. And therefore, this alkyl halide, it formed the double bond, right? And then what did we use during that reaction of elimination? We used the substitution, we used as elimination reaction, the E's. We can use E1, E2. So we use the E reaction to form an alkene. Remember, again, we have the substitution reaction. The substitution reaction, which is SN1 or SN2, it's when an alkyl halide, it forms an alcohol. Remember, when an alkyl halide forms an alcohol, and then this alcohol, as much as we learned here under dehydration, this alcohol will undergo reaction to form an alkene. But you have to be careful. The alcohol that will further undergo the alkene, it's supposed to be either tertiary or secondary. Be careful of that, okay? And therefore, alcohols from an alkene, we use the tertiary alcohols. Be careful of that. So what did we use here as a reagent? We use strong acid, which is H2SO4. You can also indicate that with water there, and then temperature is not that needed. It depends on the reaction, whether you need 50 degrees or 25 degrees for this reaction to take place. And therefore, I will see you on the next video.